Hi, welcome back. Another exciting adventure in the cloud and how to engineer it. Today's episode is no singletons in 12-factor apps. And we're going to use PCF as the demo, but a note that this will work in Kubernetes or PaaS hosted or VM hosted software as well. So why not have singletons? Well, it's against 12-factor principles. You can go read all about that on 12factor.net. It's a single point of failure, and those are always bad. And even on container systems like PCF or K8s, where health checks can detect crash processes, you may not be able to detect a stuck one. So it's a bad smell, but there are times when you're trying to access a resource that can only be gotten to realistically by one process at a time. So file I/O is a classic, or printing to a label printer is a classic. There are lots of singleton examples in the universe of the Internet of Things and any other kinds of hardware interfaces. And of course, the one that developers deal with every day is file I/O, and that includes file transfer protocol or anything like it. So how do we avoid doing that? Well, the answer is an election pattern. And in an election pattern, we have an observer whose job it is to be the repository for which instance is currently the authorized instance to process. So fundamentally, what we're talking about is a cross-process, cross-machine, maybe even cross-network mutex. Instance one can be processing and the other instances can't, or some combination, but only one at a time. So here's our starting state. Our starting state is instance one has got the ball, and it has what we call a rolling reservation. In other words, it won the election, and every time that it subsequently goes and checks to see that it's still the primary node, that date timestamp is updated as a rolling reservation that the instance one still owns the reservation and is processing along. The other ones check and they immediately bounce. They don't have the primary role. So they're in a non-primary or secondary role, and hence they do nothing. So instance 2 and instance 3 are just asleep, doing their thing, and instance 1 dies. And when instance 1 dies, if it dies ugly, what will happen is its reservation will expire. And if it dies in an orderly way, we can actually trigger an election. But we'll just assume the worst case. It dies ugly, right? It nims, it doesn't get restarted. And so what happens is the observer, in this case, the Redis provider, as instance 2 and instance 3 poll to see if they're master, at some point it will come back and say, the reservation is expired. I'm going to honor your reservation request. And now instance 2 is the primary. And if instance 1 comes back alive and instance 3 continues to go, and they ask, they will again be told they are not primary, and they'll just be idle, they'll sleep. And why we're using Redis as a provider in this demo is that Redis is really, really fast. It's available in almost every environment. It supports transactional behavior, so that moment of interaction where we go, am I the master, and we read and write, in this case a string in Redis, is going to be a success or failure type of thing, so that we're guaranteed that the observer is exclusive. There can't be a use case where more than one instance is right that to make a reservation will succeed, right? And so that's really important. And, you know, you could do this in a relational database, but you run the risk that A, it's going to be a lot slower, and B, that there could be lock escalation. It could be messy. So Redis was really designed for this sort of thing, and it's great at it. So here's the demo. Here we are in Visual Studio from the code we pulled down from GitHub, and you can see the primary actor is an interface called electron that defines how the elector model works. The core of that is the primary interface method, which returns either true or false, which is easy to use. So in goes elector info, and we'll look at that in a minute, and out comes I'm either primary, I'm not. Secondarily, if you have a situation where you have an orderly shutdown of a primary process, and you want to make sure that instead of waiting for the lease to time out on who primary is, that you can force an election early, then you can call force election. But you don't have to. It's optional. And then there are some methods that are used to set and get the expiration. In other words, how long the primary has to call primary again before its tenure expires and somebody else could grab the main spot. Now, there's nothing prohibiting the same process from grabbing the main spot again, but they would have gone through the election process. So let's look at the concrete implementation of primary. And before we do that, let's look at how simple elector info is. So elector info is a simple class that has an application name. And so every unique application name will have its own pool of instances or electors. And so that is how you separate one pool of electors from another. So if I have 2 apps or 3 apps or 4 apps that do completely different things, but they're all singletons and I want to separately scale them, I just need to make sure that 2 things are true. One is that they get a different application name from the other. In other words, the FTP file processor has got a different application name than the file share file processor. But that for all instances of, for example, the file share file processor, the application name is the same. Then we have a unique instance ID, and typically just setting this to GUID new GUID is great, unless you have a way of externally getting instance information from, say, PCF or Kubernetes, and even then, maybe it's nice to just generate one. And then the last call UTC, which is that date time that remembers the last time that the primary asserted that it was master. The provider implementation has to manage this date on the behalf of the end user. So you shouldn't have to care about it. But we expose it as a property you can read if you want to for logging or whatever. And then there's a tiny process that sets that to right now as a little function. And then we have a way of printing out the nice toString of the object. Notice that we ignore the date field for this purpose. So now that we know that, we can go look at the implementation. So we're using as our using statement the brilliant Stack Exchange Redis and the is handy Newtonsoft JSON library, and we're going to fire this thing up in the constructor and make sure that we have a valid Redis configuration, and if we don't, we're going to complain and blow up. And then we see the implementation of primary, and you can see we define the connection multiplexer, which is effectively the connection to Redis. We define an instance, and we define a transaction scope, empty. And then we define another elector info implementation and an expiry. And we go ahead and try to connect to Redis. Notice that if this fails, that am I master will in fact fail as well. You'll get a false return back. But if it succeeds, it's going to connect to Redis. It's going to connect to the database. It's going to start a transaction, and then really simple business logic to see if it's the master. And in fact, if indeed the expiration, this logic, if the master's record has expired, we're basically going to trigger an election by setting whoever's calling me right at this instant to be the primary record. And then we're going to execute that transaction. And what that makes sure that that happens is there can only be one writer at a time. And if this logic is obeyed, then subsequent attempts to write the same record until expiration happens will fail. And then we dispose of our objects in the finally block. So there we go. Notice that if this throws, it will execute the finally block and clean up our Redis connection. But because this is a low-level API, we want to go ahead and let it throw right from here. Notice if I want to force an election, all I have to do is provide it an empty, a nonsense elector that expired sometime in the darkest past. And that effectively means that the next live process that calls am I master will succeed, because this logic up here that checks the expiration will execute and it will become the new master or primary. So very simple using Redis, and then we implement the other functions. So let's take a look at a little sample program that we're using to simulate this. So this is a little .NET program, and it's written in .NET Core. And so we're going to create some logger objects, and we're going to get some assembly information so we can print that out to the logging stream. And then we're going to say who we are by creating a new elector info, and you should have this be consistent for the entire duration that the application, this application instance is running. And you can see that we're just using our friend GUID new GUID toString to get a unique identifier. Again, if I were running this in PCF or Kubernetes, there could be another unique identifier I could use in its place. It doesn't really matter as long as they are unique. And then I'm getting my Redis configuration information. In this case, we're using my little library that gets it from PCF's vcap info, but it can also get it off a JSON file in the file system, and you can see our other videos about that. We set up our Redis elector provider. We set the desired expiration time in milliseconds. And by the way, it's important here that when you set your expiration milliseconds on your provider, that two things are true. One is all instances of the same application have the same expiration. And two, that the expiration time is longer than the time it takes to do 1 unit of work, plus some comfortable margin. So it's okay to call MI primary over and over and over again too soon, but what we don't want to do is constantly have an election going on because, or worse, having double units of work being done because our expiration was too aggressive, and that actually allowed two processes to get at the same singleton thing we're trying to work with at a time. So always make sure that your expiration is longer than your unit of work. And so you should do some timings and figure that out. So we have our little loop that says, it's an infinite loop that says, while I should run, ask if I am the primary. If I am, throw some dice. And if the result is over 70, we're going to simulate a fault. And a fault means that this process just stopped working. So I'm going to do two things. One is I'm going to force an election because I was able to trap what happened and force an election explicitly. And second, I'm going to go to sleep for some long period of time to simulate the fact that the health check may have caught it and restarted it, but that takes a really long time. Otherwise, I'm going to do my fake unit of work. Happiness ensues. Otherwise, I'm going to do nothing. And in fact, I'll just wait some reasonable timeout. And the timeout we recommend is the minimum expiration in milliseconds. And that's what I'm doing here. And that infinite loop goes over and over and over again. So if I have 3 instances of this running, all banging away, then what's going to happen is that one of them will become primary almost immediately. And it'll run until a random dice throw says it should fault. And then it'll start an election, and then someone will win the election. And it could be this process, but it's unlikely. But it will probably be one of the other processes. So we'll give that a go in a minute. And that's basically all there is to it, right? So in the real world, of course, you wouldn't be inducing a fault. You'd just be doing a real unit of work. And of course, if you're not, and then so you would just do, but you probably still want to do this waiter part. Okay, let's go ahead and build this code. In this case, we're going to build it for a Linux target because it is .NET Core, and that'll let us run on PCF on a really minimum set of stuff. Our app is all built and deployed, and you can see by executing the cfapp command that we have 3 instances happily running up in our PCF foundation. Okay, let's look at our log files and we'll watch and see what's going on. So you can see that if we scroll up a little bit, let's find where we started. So we announced what you can see all 3 of them firing up and announcing who they are. And you can see 6C was voted to be primary, and it merrily went along and faulted. 74 called at about the same time, discovered it wasn't primary, and it got elected primary, and then it faulted. And then 6C won the election again, and that's all there is to it. Pretty much a little bit of setup to fire up the Redis provider, and then a call to am I primary, and you can handle your singletons with high availability. By the way, you can go get all of the software, including the provider that does this work and everything, on my GitHub site under Blitzkrieg Software, No Singletons.